Good afternoon, everybody, and welcome to the TNITS webinar on specification. As you can see, we will be together for 1 hour and a half, and this is our agenda for today. The speakers will I will be moderating this webinar, and the speaker will be Christian Klein from here, who will introduce us to the TNITS platform, Stefan Sjöbel, who will talk about the working group 2 of TNITS and the specification, and Knut Jedlund that will dive in a bit deeper on the specification, the technical specification. Then we will have Peter Colbert that will talk about TNITS and open data, and Frank Dams, the coordinator of TNITS, that will guide us through the next events and the next activities of TNITS. Before we start, a few attention points. So this webinar is recorded and will be made available online on the TNITS website and also through the Article channels. The list of attendees, your name and organization will be included in the TNITS Go project's deliverable and will be shared with our stakeholders, so the Commission and our members as well. By being present, you agree that TNITS obtains the right to share this content. Further on, for your questions, please type your questions in this box, in the box question, and I would kindly ask you to write the name of the person you're asking the question to. The questions will be answered either at the end of each presentation or at the end of the webinar or offline. We will see how much time we will have. So this is all from my part. So now we can go on and start with Christian Klein, who is Manager Data Acquisition at HERE Technologies and also the President of the TNITS platform. He, as mentioned, will give us a brief overview of the TNITS platform and its main activities. Please, Christian, go ahead.
Okay, thanks a lot, Carmela, for this kind introduction, and also welcome from my side. As Carmela already mentioned, I will give you really just a short overview of what is TNITS before we deep dive into the specification with all the other presentations. So first of all, what is TNITS? TNITS stands for Transportation Network for ITS, and it's a trusted and market-driven mobility data exchange framework. It's also an innovation platform under Article. It's a technical specification under SEN on what we are talking today about. And also it is one of, or we see it as one of the important building blocks for today's and future's mobility data space. What is it all about? So it's really about exchange of data on a road attribute. So all kinds of signs and road data which is used in digital maps for intelligent transportation services. So for example, our focus is really on road attributes which are really based on regulations like, for example, speed limits, but also other restriction warning signs, as you can maybe think about, for example, truck restrictions or some other restrictions which are posted on signs outside. So this is really what we are concerned about in TNITS. Where is our position and role within the digital mobility infrastructure? So TNITS is really a framework for the data chain between road operator, public authorities, via the national access points to service provider, which then will use this data for their services, for maps, and then deliver it to the end user to enable end users to have really fresh and reliable and trusted information via this data chain. I already mentioned the TNITS innovation platform. So this is our association where we really want to foster the exchange of road data inside EU. This the innovation platform is coordinated by Article. We have members from road authorities, but also map makers. And associations like ETSC and also Ertico and ITS United Kingdom. Yeah, we're supporting EU policy on data sharing. We are really working on standardization, so we are really giving input to the standardization bodies on the usage of the standards. We are giving implementation support to newcomers to Tiana ITS. We are also doing this via projects like our current project Tiana ITS Go. So if you want to have more, if you want to know more, you can also find out on our website. Yeah, so just to conclude and just to point out the benefits of Tiana ITS, so it's already really a proven process for map update exchange. So this is really something which is already being used. It's as I mentioned, a trusted and reliable fresh source because it's coming directly from road authorities. One main benefit is really to have incremental updates, so it's more efficient because it's really pointing to the changes. So then so the data user can update their maps much faster. We have the possibility to have it really in daily updates, so really a near real-time process. Yeah, I already mentioned standardization, which is good because then everyone is following the same process, and ingestion on data user side is even easier. It's machine readable, so and this has a high potential, and it's already being used in automated processes. So, and with this, I conclude and I hand over again to Carmela.
Thank you. Thank you very much. Thank you very much, Christian, for this presentation. And after the overview on the Tiana ITS platform, let's proceed with the introduction to the Tiana ITS specification. It will be Stefan Siobel who will take the first part. Stefan is an expert in digital maps and leader of the working group 2 on specification at the Tiana ITS platform. Stefan has been involved in Tiana ITS since its foundation in 2013 and will illustrate the activities of the Tiana ITS Working Group 2, the specification maintenance, and the liaison with other organizations. Thank you very much, Stefan. Please go ahead.
Okay, thank you, Carmela, for the introduction. So I will guide you through the Working Group 2 activities. That's where the focus is on the technical specifications. This is the overview of my presentation, so please be patient. I will give some technical terms, but they will probably be more explained in detail in the next slide by Knut Jetlund. So I will give a short introduction to a number of key projects which have led to the technical specification. I will, as I said, elaborate a bit on the work of Working Group 2. I will explain the liaisons and I will conclude by an outlook. So without further ado, here are 5 key projects which have led to the technical specifications and the change or the maintenance of that. So dating back from the early years, in the years 2000 we started with projects where car manufacturers and map makers united to learn what type of map information is relevant for advanced driver assistance systems, and also which type of technologies are needed to maintain these digital maps. So from that input, we moved on to a project called ROSAT, which looked at the exchange of road data from the side of the road authorities to the side of the map makers. There we had a number of road authorities involved in Europe that contributed to the activities. And basically, we had the first technical specification for the exchange infrastructure ready by 2010. Then later, with the transportation pilot project, we matured the ROSAT technical specifications. We also did some cross-border pilots testing of the data exchange infrastructure. All this work led in 2018 to the release by CEN of the technical specification 17268. So a dedicated project team worked on that, and there the input was, of course, what was done in the past, and alignment with a number of initiative and ISO standards were reached at that time. So moving on, by the end of this year, we will conclude the TNITS Go project, which basically will, we will have 14 European member states setting up TNITS Go services. We will learn about new attributes which are important for the users and also the providers of the road data, and we will continue the connection to other standardization bodies. So moving to the future, what is an anticipated initiative? It's the National Access Point Federation. So TNITS, especially the specification work, will play a role in that initiative, and there we will seek alignment of the specifications with other groups, from example, the traffic information group, the public transport information group, and also a working group on metadata. So what is the working group specification all about? So it was established at the launch of the platform in 2015 as one of the several TNITS platform working groups. First, it was chaired by the Norwegian Public Road Authority, and now it's represented by Etico. The mission is to maintain a pool of experts, to review incoming requests for changes of attributes from stakeholders, the maintenance of the code list of the technical specification, and Knut will explain what it is all about, the connection to the relevant activities under SEN, and contribution to the worldwide standardization effort. And of course, we are doing that within consultation with other working groups within TNITS. What are the roles and achievements? So the working group 2 promoted the development of SEN technical specification. So it did not actively work on it. That was a dedicated project team within SEN who established the technical specification, but the activities were promoted by TNITS specs, but also by the European Commission. The group hosts the XSD schema files, the code lists, and UML. Again, Knut will explain what it is about. We defined a formal change request procedure, and we also develop promotion material. Now, a word about extending the technical specification. What are the main sources? Well, on one hand, you have the information coming from, I would say, the external world, and in this case, it's the safety-related traffic information, the SRTI. So that initiative describes also static data, which is, of course, our field of expertise. When you look at the technical specification of TNITS, what it covers, it's already shown in green. So quite a lot of what is proposed or defined in the SRTI is already covered by TNITS. There are, however, some areas indicated in orange, for example, the urban vehicle access regulation, where more work needs to be done. On the right-hand side, we show the extensions coming from TNITS Go partners, and those are mostly code list related. So not core feature focused changes that are proposed or updates, but it's more like information that you can support by extending a code list. So road length, lane count, official name are examples of that extension. Of course, we're not doing that work all by ourselves. We have formal and informal connections. So formal, it's with the SEN Technical Committee 278. We have applied as TNITS Go to become a liaison organization. Informal connections are with different groups, either coordinated by Etico or not by coordinated by Etico. Think about the traffic community, the traveler information community, the traffic management community, the vehicle sensor data community, the community focusing on the interface of the map and control units in the car, ADASIS. There's also the connection to the Open Autodrive forum, so the connection to the automated, connected and automated mobility community. And then there's also the connection to traffic regulation, so digital traffic regulation initiatives. And last, there, of course, there are links outside Europe with different organizations in Australia, US, and Japan. So the way forward, what's going to happen on short and longer term related to our working group activities, the update of a technical report on the maintenance of the specification, which will be published in Q3 this year. We will continue to guide authorities and member states who have old services running on older specifications to do the transition to the TNITS specifications. We will continue to support our members and others, for example, by expanding the toolset to verify the compliance to schema definitions. We will continue to further align with related standardization and initiatives and groups. We also will take up a role in the National Access Point Federation. And as you will later hear from our friend Peter, we will reach out to the linked open data world. So, for example, explore the steps to take towards the TNITS vocabulary. So that's it from my side. Back to you, Carmela.
Thank you very much, Stefan. We have a few questions, so I have one for you now. The other questions we will ask them at the end after all the speakers have presented. So could you please tell us what are the strengths of the TNITS technical specification and if there is any drawbacks?
Well, the specification are the result of work done in several pilot projects. I mentioned that with at least over 20 parties in the authoritative area and in the industry area. So I think we reached a mature state regarding the technical specifications, and these serve to make changes of road data available to MOP and service providers, but not only to those. About 90% of all the TNITS services, they publish data under an open data license. So it's the data that is published is reusable not only by the leading map makers in the world, but also by community much wider than that. So the specs are flexible and they allow for local extensions. So that's good. Now, on drawbacks, so the specs are, I think, okay. They need more work to realize harmonization between the standardization groups, but I think we can improve on increasing the awareness and the recognition of the technical specification. So also outside Europe, my ambition is that TNITS is not only recognized outside Europe, but also used. So for example, if a data sharing services in Australia or in US is being set up by the authorities, that they would use the TNITS specifications. So we are not there yet. We need to promote it a bit more actively to increase awareness and recognition.
Thank you very much, Stefan, for your answer, and I totally agree to that. We are working. We will be working on that. So now, after this overview, we will be diving a bit deeper on the technical side with our next speaker, Knut Jetlund, who is a PhD in geomatics and a standardization expert at the Norwegian Public Road Administration. Please, Knut, go ahead. We cannot hear you yet. Maybe you can unmute yourself.
Okay, you can hear me now?
Yes, we can. Thank you.
I cannot see which screen you see the presentation, do you know?
Yes, we do. We see the correct screen.
I can only see a big picture of myself. Okay, thank you, Carmela. So before I start, I have to say that some figures in this presentation are quite detailed and technical, and they may be hard to read. So, but however, the presentation will be made available for you afterwards. So if you're interested in studying the details, you may download the presentation later. So for now, I ask you to just focus on the bigger picture. So I'll just start here. As already explained, we are talking about the authoritative information needed for legal and safe navigation in the road network, such as speed limits and restricted maneuvers. This information is maintained by road authorities at different administrative levels and mostly in systems from the application domain of Geographic Information Systems, GIS. So the Tnits specification defines the mechanisms for providing the authoritative information from authorities to map providers for ITS, as illustrated by the arrow here, in order to ensure information is available for road users, either they are humans or automated vehicles. So the Tnits specification is based on a generic and flexible model. It's prepared for implementation in different technologies, as we will see later here. So it combines concepts that are defined in standards from the GIS world as well as the ITS world. It's modeled in UML according to ISO TC211 rules from the GIS domain and implemented in the standardized GIS exchange format, GML. And furthermore, the specification describes location referencing based on standards from both the GIS world and ITS world. And it incorporates models from DataX2 and from ISO 14823 for traffic signs. So it's a generic model and it integrates standards and specifications from the GIS and the ITS world. As I said, some of these slides are a bit technical, so once again, please don't look at the details, look at the bigger picture. I will present two slides about the technical foundation for the Tnits specification. First, an essential fundament for information modeling in the GIS domain is model-driven architecture, as illustrated in this picture. In model-driven architecture, you develop models at different levels of abstraction, from the meta models to the conceptual schemas and the implementation schemas. The conceptual schemas are independent of any implementation technology and can therefore be implemented in different technologies through conversion rules. As shown here, the Tnits specification is developed as a conceptual schema and is therefore technology independent. The model is based on the core abstract concepts from GIS standards, for example, for geometry and time. And from the UML model, we have derived implementation schemas for GML through the conversion rules. This is essential for a model-driven architecture, and especially other technologies can also be implemented, and this is essential for model-driven architecture. For example, the OWL implementation could be a relevant extension in the future, which Peter Colbert will talk about later. And then I have one more slide about the foundation for the specification. The other essential foundation is that we acknowledge the need for an open classification of an evolving real world, which also relates to the semantic web and the linked data approach. The classification we use to describe the real world needs to be flexible, as we do not know everything about the real world at any time. We need to follow an open world assumption where we can add more classifications as we learn more and as the real world evolves. This is contrary to the closed world assumption, where we can create fixed models that we assume are complete. The difference between these two assumptions can be illustrated by the picture on the right here. At some point of time, Europeans assumed that all swans were white. A classification system based on the closed world assumption would not allow for black swans. which we know that exists. So contrary, in an open world assumption, we will only state that we know that some swans are white. So the classifications need to be flexible. And before we now dive into the model, let's define some of the terminology that's used in this presentation. First, a feature, when I talk about a feature, it is a digital representation of a real world phenomena. For example, one instance of a restriction in the road, a speed limit or a forbidden maneuver. The schema is the formal description of the real world concepts, the structure of the digital representation of the restrictions. And then we have the code lists, which are the classifications of the real world, for example, as speed limits or as access restrictions. And finally, we have the feature catalog, which is the container that holds the feature and property classifications. So with these terms in place, let's dive even more into the details. And the core of the Tnits specification is the generic feature exchange model, which we recognize from the overview figure we saw in the previous slide. All features are described as instances of the generic class road feature, but assigned with a type. The feature can have properties which are also defined generic in the model, but assigned with type. The classifications of types and other attributes are described in code lists, a term we also remember from the previous slide now. And one example of a single feature instance can be that we have a road feature with a road feature type speed limit with a property with a maximum speed limit. And the maximum speed limit has a value and it has a unit of measure, kilometers per hour. And by defining a generic feature exchange model and the classification in code lists separately, the model can be used with different classifications and with different versions of this. So the standardized classification in code lists that I talked about are available in the Tnits schema repository. And as we saw in the previous slide, the code list are instances of the feature catalog. One example of a code list is the standardized road feature types for the road feature type here, as we see in the example here. This code list contains a value speed limit, and therefore that value may be used as a value for the road feature type. And please note here that the implementation would typically not contain the word speed limit. It will contain the URI that refer to the code list value in the code list on the schema repository. And there are several advantages by these external code lists. First, we have a set of standardized code values that can be used independent of service provider. And second, we have the flexibility to extend the code lists without revising the whole standard or the technical specification. And finally, we are able to have different code lists for service providers. So each service provider can extend the code list with their specific values that are unique for their country. For example, I doubt any other country than Norway need a sign for polar bears. So this approach with a generic model and external code lists is an essential foundation for a Tnits specification with a combination of the standardized values and the flexibility for extensions. It's also an approach that is very close to the semantic web, and this code list may very easily be converted to OWL and RDF. The specification defines several methods of location referencing. None of these are mandatory, but every road feature shall have at least one location reference. And we have dynamic referencing, which is preferred by the map providers, where you can use Agora C, which is standardized but licensed, or you can use OpenLR, which is an industry specification, but it's open and free to use. You can also have linear referencing, for instance, for looking up on Inspire Transport Network road links. And you can have location by reference. For example, when Sweden switched from 90 to 80 kilometers per hour as their general speed limit, you could refer to Sweden as the whole country instead of having a unique location reference for each speed limit. Or you can have location by geometry. For example, for low emission zones used for geofencing, you can describe a polygon. And besides the classification of road features and the properties, we also need to be aware that restrictions can be valid under given conditions. This is handled through the conditions model, where conditions can be related to areas such as inside or outside cities, near schools or something. You can have lane numbers, you can have weather conditions such as snow or fog, you can have time periods, road categories, and you can have vehicle characteristics. And you can also have combinations of these. If we look at the examples in the pictures here, unfortunately in Norwegian, you can see the first one defines restrictions for the weight of vehicles in a given time period, in the most busy time periods in the morning and in the evening. As this tunnel is very steep, that's why we have the restrictions there. While the other one restricts access for all vehicles except for buses. So these kind of conditions can be described by the model. And as mentioned earlier, the Tnits specification incorporates models from DATEX 2, the validity model for defining time periods and a model for vehicle characteristics are adapted into the Tnits model and are transformed to be compliant with the modeling rules in GIS. This way, conditions related to time and vehicle characteristics can be described in the same way in Tnits and in DATEX. So time periods can be described as special days or public holidays or something. You could have a time period during a day. You could have special days during the week, special months or something. And you can also have fuzzy time periods like during the winter or from dusk and dawn or during school hours or something. For vehicle characteristics, you can have also several kinds of classifications, such as height, the length, width, the gross weight, number of axles, and the heaviest axle weight characteristic, and also what kind of emission class the vehicles are in, which is very relevant, for instance, for geofencing. And finally, the Tnits specification, as I said, has also adopted the classification of traffic signs defined in ISO 14823. While the generic road feature property can be used for describing any kind of property defined by the road feature property type, the road sign property is designed specifically for describing traffic signs according to ISO 14823. And in ISO 14823, signs are classified with a GDD code, which is a combination of a service category and a pictogram category. So as this example shows, a sign for maximum speed limit is in service category 12 and with pictogram category 557. In the code list for road sign type, we can find the same sign represented with its GDD code 12_557, which can then be applied as the GDD code of a road sign property. Besides, the sign may of course have a value or a text, depending on the type of a sign. A speed limit sign must of course have a value. And of course, signs that are not defined in ISO 14823 may be provided by the generic road feature property. So finally, the resources needed for implementation of the specification are available in the TNITS schema repository as a set of standardized code lists and as a set of GML schemas. And as stated earlier, the code list contains the core standardized values, and they may easily be extended by defining local code lists for values specific for individual service providers. So this was a quick and brief introduction to the specification. I also given a presentation earlier, which you see a link to here, where you can find more details. And also, if you download the presentation afterwards, you will also be able to study the details on my slides. So that's my presentation, Carmela.
Thank you very much, Knut. We really appreciate your comprehensive presentation. And as you mentioned, there is a separate workshop on how to implement the specification. And the slides will be shared shortly after this webinar. So you will have all the information, and you could check the presentation themselves and the link. We have a question for you, Knut. We have a couple actually. First one would be, how do you create local extensions to code lists?
Well, the code lists in the schema repository may be used as a kind of a template for local extensions. So you simply create your own code list with the values you need in addition, following the same structure as in the official code lists. So you can create a code list for, like I said, for polar bear signs or something.
Okay. Thank you very much. And I can also see another question for you. We have another few minutes, so maybe we can answer this already. So does the TNITS specifications cover hill inclinations and road curve radius of road segments? I think these are very specific requests, but...
Yeah, could you repeat the question?
Yeah, of course. So the TNITS specifications so include things such as hill inclinations, so I mean the steepness of the road, and the road curve radius. So for example, when you have a very dangerous bend because of its radius, are these features that are considered?
Yeah, I understand the question. Actually, I must admit I don't quite remember those details about the content of the code lists, but I think you have at least code lists for or values for particularly steep segments, things like that. Not for general descriptions of the steepness, but for segments that are specifically steep. And if they're not there, if they're needed, you can either create a local code list, or you can ask for it to be extended in the official code lists.
Okay, perfect. Thank you very much, Knut. So I think we can now go to the next presenter. We're very happy to have with us Dr. Peter Colbert. Peter he's a postdoctoral researcher at ID Lab and Ghent University, and he will talk about TNITS and open data. I will be presenting your presentation for you.
Yes, so, please.
Of course. Just a minute.
I found out a little bit too late that GoToWebinar doesn't have support for Linux, and I don't have a Windows machine or a Mac.
No problem. Now
yeah.
we know for the next time. I trust you can see my screen?
Yes, I can see it.
Perfect.
Good. Thank you everyone for giving me the floor for 10 to 15 minutes on open data and TNITS. I'm not a TNITS expert, but I am an open data researcher, and I think that that we can work together on something that's much greater than just only the TNITS world. I think open data has the opportunity to go broader and to make sure that we link up to other domains as well. So if you go to the next slide, Carmelo, then I want to show you what the current state of open data is. If you go to data.europe.eu and we look for TNITS, then we find a lot data sets that are already in a TNITS format. However, and if you go to the next slide, then you'll see that if you just select the first link, for example, and you click downloads, that you already bump into all kinds of problems. So next slide is the truth is, with open data, we are still taking baby steps, and that's not a big problem, because next slide is that there's a picture of me and my baby. My webcam doesn't work, so there you see what I look like. But that's my baby, and while it is horrible to spend the nights awake, and while it is a pain in the beginning to take care of a baby, it's really tough. You know that the baby will grow up, and I think that also for open data and TNITS, we have to look at what the future will bring. And as a researcher, we've created some prototypes already. Next slide. Over here you will see it's a prototype that we did. I'll share the link also in the chat if that's possible. But if not, just check out the links in the presentation that's going to be shared afterwards. This is an in-browser demo that you can just pick two dots on a map. And from that moment on, your browser will start looking for the right data sets. Over here, we also controlled the roads network itself, so we cheated a bit. We were looking for guidelines to give towards the Flemish government to say, like, how do you need to publish your road networks as linked data, and what can you what would be interesting ways to do that, so that we can go towards automated reuse of these data sets for route planning. We republished that data set in the way that we see as the perfect way to do it. So what is this perfect way exactly? Well, for one thing, we know for sure, next slide, is that it requires interoperability. So in order to make automated reuse of all these data sets that are published online, whether it's a transport data set, whether it's about road networks, or whether it's about public transport, or whether it's just geospatial information, or whether it's any kind of statistical open data sets, we need to automatically detect whether this is something that we can use to calculate a route for. And of course, with open data, you can never assume for which use cases exactly it's going to be used. So it might be even that a statistical data set may in the end be useful for route planning. For example, if you're a young attractive female and you want to route through Brussels, I'm pretty sure that you want to maybe avoid certain parts that have a high criminal statistic, for example. So your route planner could actually also take advantage of these kinds of statistical data sets in order to involve in your route planning. But how do you discover all these data sets just in time? We have some ideas that we published in that paper, but I think the true keyword here is interoperability. So let's look at interoperability and how Europe is defining that word. There's the European Interoperability Framework, EIF for the for the people who are acquainted with the European Interoperability Framework. But it's a lengthy document in which there are a lot of recommendations, and they're kind of high level. They hint towards technical ways of implementing it. But I must say I really like this framework. It sketches all the recommendations that I also try to implement. But what I then try to do is to also translate that towards technical protocols. So read up on the European Interoperability Framework, because it's a really interesting document about interoperability and how to make sure that this automation of the adoption of open data sets that's being created in the years to come. Next slide. But if we then look at what is all defined in this EIF document, then we're looking at, for example, technical interoperability, or that's the first big one. And I think that's the only one that we already tackled in a sufficient way, because we have the HTTP protocol that allows us to just share a URL, web address of a certain file, and we can be sure that if we fill it out in a browser, or if we HTTP request it in our programming code, that we will be able to access its contents. And from the moment that we can access its contents, then we of course need to go into syntactic interoperability, because with syntactic interoperability, well, there we are looking at serializations such as XML, CSV, JSON, HTML, Turtle, and so on and so forth. There are way more than that go around on the web. And I think that many different standards really pick one specific serialization. Just like TNITS, we are pretty dependent on XML. But why? That's what I don't understand, because TNITS is not a syntactic standard. TNITS is a semantic standard. TNITS defines a data model in which we can share more data about one specific domain, and it is complementary, or it should become complementary to transmodel, Datex2, DC terms, Inspire, and so on. But all the others, they also didn't pick one specific serialization. Okay, they originated from XML and CSV, but now they're also available in JSON, HTML, in Turtle, binary JSON, protobuf, and so on. And how do they do that? Well, now they're slowly moving into linked data. So linked data, they say, or the linked data is often pitched as a solution for semantic interoperability, but I don't believe that. As a linked data researcher as well, or linked open data researcher, I try never to pitch RDF and the linked data world as a solution for semantic interoperability. It is a solution for syntactic interoperability, because we become serialization independent. Linked data can be put inside an XML. It can be put inside a CSV, that's then called CSV on the web. Can be put inside a JSON, that's then called JSON LD. Can be put inside HTML, which is then called RDFA. It can be put inside Turtle. Well, that's actually a native RDF standard. It also has binary representations and so on. That the serialization in itself doesn't matter anymore. We can always extract the facts or the real data from it, and we can just in our programming code we will be able to deal with the semantics and not with the serialization specific things. So so I hope that TNITS really focuses on semantic interoperability, because linked data is a framework to solve semantic interoperability. It is a framework because the real things that solve semantic interoperability are standards like TNITS, Datex2, DC terms, transmodel, and so on and so forth. So my recommendation in each case for TNITS would be make sure that you become serialization independent by also publishing a linked data vocabulary. I also have then the last part, which I find to be often forgotten, and even there's not much mention of it in the EIF framework. But it was already a question in the chat over here by Julia. I think I pronounced your name correctly. If not, correct me later. Where the question is how do you include these kind of TNITS semantics? How do you include them in APIs? And what kind of APIs do we want to support with TNITS? Well, if we just publish a vocabulary, we allow everyone to define more specific application profiles. I really like this word, application profile, because it is an implementation of a vocabulary towards a specific use for a specific application. And there we can make application profiles, for example, for routing. We can also try to include it in the new OGC API, which also supports JSON-LD. The OGC APIs like the WFS and WMS, the web feature services, we can include them in there. We can also support graph queries. For example, if you want to do a GraphQL endpoint or a Sparkle endpoint. Or we could just say, well, I publish data to replicate, which means that I will publish a data dump, and you can just copy the data to your system and then expose another kind of web API on top of that. And yeah, the real question is, can our semantic model be used in any kind of API? And I believe that now, because of the heavy schema, because of the heavy relying on XML schemas, that we don't support any use case there. So maybe it's time to pull this separately and to make sure that on the one hand we have a vocabulary, and on the other hand we have many application profiles that make use of the TNITS vocabulary. So that's that. Next slide. One important remark is that you're not alone in this. Like right now, we've seen a lot of different specifications that are really tailored towards a specific serialization, such as JSON or XML or even CSV. If you look at GTFS, but now slowly we see this this separation of concerns. We see this separation thanks also to the European Interoperability Framework that clearly defines semantic interoperability as a concept. So with semantic interoperability, or by splitting syntactic interoperability and semantic interoperability, you really make the case for also only making standards in one of either. Or you're creating a syntax, or you're creating a domain model, and that's, I think, is a nice thing about this. So with Transmodel, that's now at w3id.org/transmodel. You can already find a vocabulary now that just defines a vocabulary of words that you can use in your XML, in your JSON-LD, in your CSVs, if you want, in your HTML, to point to public transit systems. Datex2 is doing exactly the same right now, making this translation. And I think the time really is right today to make sure that that TNITS follows in the same way. And then, then we have my final slide to end. So let's make TNITS work for open data. What I recommend and what I think will make a gigantic impact with TNITS for the future is to make sure that the XML schemas and the code lists also work in linked data versions, so that we can promote the use of TNITS in all kinds of different serializations and not only XML. Thank you very much.
Carmela, you are muted.
Thank you very much for saying that. I was thanking Peter for the presentation, and we are looking forward to further cooperation with Linkdata, and I'm sure we will be cooperating on this also in coordination with Datex in the near future. So I think we have one question for you now, Peter. The rest we will take it at the end of the meeting. Do we have to do Linkdata today or in 5 years, for example?
And that's a very interesting question, because if you would have asked me that question 5 years ago, I don't know what I would have answered. But today I'm pretty sure that you just need to start doing that today. We have the European Interoperability Framework that's really supporting many different European public administrations to make sure to go in that direction. We have the SEN standards of Datex2 and Transmodel that are taking the step today. And to be honest, I've been able to convince Datex2 by showing them examples in the wild of people using Datex2, which is also relying on XML or started from the XML world. I started them showing examples, different examples of people all over the world that started using Datex2, but in JSON. And they used it in totally different ways. So the purpose of becoming interoperable was totally lost, while they still claimed to be doing Datex2, but it was in a very specific way because they didn't want to use XML and they used JSON. So the worldwide initiatives across the totally different side of the world that claimed to be interoperable with Datex2, and then if you compare these two things that are created separately, it wouldn't be interoperable. You would have to code totally different. You would have to code two separate programs in order to be able to read these two files, which would have been Datex2 compliant. So that's the danger that I also see with TNITS, is what if people don't use XML and they start using something else, then they're going to create a massacre of your own specification, which focuses, to be honest, on semantic interoperability. They're going to create their own dialect of it, and all the interoperability will be lost. And that's not what we want, because we want to go towards automated adoption of this data. So really, the time is now to start jumping on that wagon.
Absolutely. Thank you, Peter. It's absolutely not what we want, and you convinced us as well as Datex. But now let's go to the next speaker. Last but not least, we will have Frank Dams, the Senior Manager at Ertico and coordinator of the Tnits platform and Tnits Go projects. And Frank will guide us through the upcoming activities of Tnits for the rest of the year. Please, Frank, go ahead.
Okay, I think you will see me, and I think I'm online now. Thanks a lot, Carmela,
Yes.
for the introduction. Let me try to organize my screen. It doesn't go to slideshow now. Thanks a lot, Carmela. And in fact, yeah, listening to this interesting webinar, I thought it was maybe a good idea to also inform you about all the upcoming events, especially for 2021 in the next slides. And there are quite a number of activities that we are planning now in 2021. First of all, we have next webinars, we have workshops, we have the World Congress coming up in Hamburg in October, and we have also, let's say, the finalization of our Tnits Go implementation project in the member states coming to the end in this year in December. And I will give an update, a kind of short preview of, let's say, preliminary agendas that we have in mind for you to attend all this interesting information. If you look to the next sheet, and I go into, let's say, the interesting next webinar that we are planning, and that will be targeted somewhere in September 2021. It's all about how maps work. So it's a kind of complementary to this very technical webinar today about specifications. It's more about how we implement these specifications and how, let's say, complex maps today that you all encounter in your phone or in your car or wherever work, and what is the role of TNITS to enable these applications. And it is, let's say, a webinar, and of course, again, in cooperation with our Ertico Academy, like this webinar is going on. And a preliminary agenda looks like an introduction, of course, general description of the map of layers, the detail on the role of TNITS in that map, and of course, building and maintaining the map attributes. How do you do that? Then a specific element on the NDS map distribution protocol, which plays a complementary role to TNITS. And we will also apply all this knowledge in a case study for a real application like the intelligent speed adaptation, which is much in focus of our intention to make the world more safe. And we will also have an outlook in this webinar on the HD maps and the technical side about it and how we move forward in these applications. So again, keep an eye on our communication, and so that we have, let's say, defined a real final date for this webinar, and it's probably a complementary webinar to your interest of this one. Within Ertico, we have, let's say, the Ertico Startups activity, which already was announced in 2019 and active in 2019. Unfortunately, not so much in 2020, but this year we revived it, especially related to the World Congress in Hamburg. Within this World Congress, there will be a kind of mini Congress related to startup and scale-up activities. And also from a TNITS point, we have in mind to launch a call for innovation, innovative ideas. So with this call that we will probably launch in June, we invite innovators to think about TNITS data and how they think that TNITS data can, let's say, be used or enhance mobility applications. But it's not only about the applications, as thinking about smart interactive new innovations on applications. It's also about, let's say, are there smart ideas on improving the security and integrity of the data, or the smart ideas on improving the accuracy and the quality of the data, and maybe any other idea that you have on this topic is welcome. So this call will be launched in the next month. What are we going to do with the registrations? The best ideas are selected, like always, and are candidates. They are candidates that these companies can pitch their idea on the World Congress on Wednesday, on the 13th of October, where there's a dedicated day, in fact, related to startups that are related to Ertico projects, and in Caso also TNITS. And these winners have also the possibility to start exposing their ideas on a booth at the Startup Village, which is on the World Congress. So the call will be launched during the next weeks. Then, besides webinars and in call to innovators, we also organize workshops. We have a few of those in mind. One is the TNITS and Sensoris. Sensoris is the Ertico platform on sensors, in-car sensors, and how they play a role in data generation, and how can we make use of this data generation. So we just got feedback from the Sensoris.org organization that had a General Assembly, I believe I think yesterday and the day before, where this cooperation with TNITS was also discussed, and we heard this morning from the association that there is big interest to look into cooperation with TNITS, where there is a preliminary agenda for this workshop. It's a kind of two-stage workshop that we have in mind. One is, let's say, a preparation workshop that will be somewhere end of August, beginning of September, where we address, let's say, a preliminary agenda, like, okay, what are the possibilities for cooperation? So we always do a sort of mutual presentations. We brainstorm about complementary between the standards, and then we come to a kind of agreement on, okay, what can we do on the definition and the goal that we can do for this cooperation. And then, of course, second part is related to desired interoperability. How do we formalize that in organizational elements, information elements, whatever possible solutions and roadmap? And then, of course, we conclude on how to progress further. Then there will be an opportunity to have a second stage after this preliminary, after this initial preparation. We will have, let's say, a kind of joint presentation towards cities, where we like to present the opportunity of Tnits and Sensoris cooperation to dedicated applications, to enabling dedicated applications for cities and city authorities. Then on the World Congress, on the World Congress itself, is from October 11th to 15th. We have, like always, a Tnits booth at the Ertico site. There will be also special interest sessions organized on that. And we also will announce the final event on the Tnits Go project. The workshop that I was addressing in relationship to the World Congress is the Tnits Goes Urban workshop. In this workshop, it's a cooperation with the Ertico City Moonshot initiative that Ertico is doing, and there is also a preliminary agenda for that. So the topic is we want to give feedback to the cities about how data sharing is used actually. So there is quite an insight in the City Moonshot study of Ertico that addresses 350 cities across Europe, mainly across Europe, but also outside Europe. And that has built up quite a knowledge database on how cities are acting with mobility data and how they share it and why they share it and for what purpose. So we will introduce, of course, the subject of Tnits in that data sharing aspect. We will have Hamburg having a small introduction about how they act in their own open data portal, and we will have, let's say, city-related applications that are based upon Tnits. We have two innovator companies that will talk about innovative applications based upon map-related data, especially to city-related concerns like, do we guide the traffic at the right place? Do we make sure that, for instance, we can avoid schools and hospitals for dangerous traffic? That's one topic. The other topic is more like the data management itself. So there's a really very interesting introduction, where then in a, let's say, second part, we address a workshop addressing, let's say, the roadblocks or the data sharing. Why is it possible or not possible for cities to share data? What are the roadblocks, the socio-economic aspects, the policy elements that come up? So we like to have quite a good overview on that. And after a short break, we, of course, the whole workshop is then about how can we mitigate these roadblocks and how can we help cities to accomplish solutions for their needs related to mobility data sharing, and how can Tnits play a role on that. And then, of course, we hope to come up with conclusions on it. This is quite a workshop, and it's going to take place at a certain place that we are still discussing at this moment in the neighborhood of the World Congress in Hamburg, and it's going to take place on Monday, the 11th of October, from 12:30 till 15:30, which gives you the possibility to enter the Congress at the right time, because the Congress will start right after that. Final event is also on the agenda. This is the final event of the Tnits Go project, implementation project in 40 member states. And this is already planned. The date is targeted the 2nd of December 2021. And we are looking to the program definition for that in detail, where we will invite, of course, let's say, people from the EC and to explain what has been achieved with the project, the role of Tnits, how we move forward, and all these aspects will come back. And of course, we will also address the success stories that member states have established the fine result of, let's say, the implementation. The status of that is that, well, we are now, most of the countries have, let's say, finished their implementation, and I think a lot of people are now busy to evaluate implementations and to maybe to do the last corrections to make sure that member states have, let's say, the pilots running by the 2nd of December, so that we can show the results. Okay, this is quite a lot of activities, and of course we welcome you as an audience to all these activities, and glad to have you here, and outlook to the future. Camilla, I think this is my presentation.
Yeah, indeed, thank you very much, Frank, and it looks like a very busy end of the year, second part of the year for TNITS. We are very excited to and look forward to it, and will of course be very happy to welcome you all during our activities. Now we have some questions. I will be presenting them, I think. Yeah, here we go. So, and the first one is, are there public databases with TNITS data for EU public roads, like speed limit, etc., and in which member state, and how to access those data? Maybe I can start answering these questions, and I would kindly ask my colleagues, my speakers, to help me with that. So yes, the public database of TNITS are currently available in a few member states, such as Sweden and Finland, Flanders, which is a part of Belgium, and these are already active services that you can find either via the links available on the TNITS website, or via the NAP, the national NAPs. By the end of this year, when the completion of TNITS Go will be finalized, we should have a few more active services, namely in France, in the UK, and also we have one in Hungary, and and in Ireland as well. And of course, we will be supporting the TNITS Go member states that are implementing pilots as well. So you will also have links to pilot data, the pilot services that the member states, the 14 member states of TNITS Go, are all committed to make them available, first of all, via the NAPs, the national NAPs, and also to make them actual services as soon as possible and compatible, with their national timetable. I don't know if anybody wishes to add anything else. Then we can go to the next question, which is, are there processes in place to help integrating data into TNITS supplied by road authorities and other data sources? I'm especially interested in the process of establishing APIs and streaming data models. I know that Peter mentioned this question beforehand. Maybe Knut wishes to say something?
I think maybe Stefan or some others could say more about that. I'm more into the specification and not into the APIs.
So, Stefan?
Yeah, just a comment from my side. I don't fully understand the question. It looks to me as if the question is addressing what I would say upstream situation, like when an authority has authority has the technologies in place to maintain their own databases and then decides to publish the changes of road data in a TNITS conform format, that this interface, that there would be some processes in place. If that is my correct understanding of the question, then I can only say that it's really it's like a bespoke situation at the side of the authorities. It depends very much on which platform they use to maintain their own database and to create TNITS compliant data sets. I don't think there are like generic solutions for that. It depends very much on the technology stack they are using to maintain their national road database or their road database in general.
I want to add to that I find this question spot on. I find it such an important question that needs to be asked, and also that we might want to try to move into giving documentation towards how to publish an event stream, and then of course with then linked data added to it. So a linked data event stream, that would be great. There's just a new specification published by the European Commission at w3id.org/LDES. So linked data event streams, LDES, which really tries to show how you set up such an API with any kind of linked data model. So if TNITS would become a linked data model, then you would be able also to use the linked data event stream specification to set that up. And yes, then I follow also Stefan's reply that how to implement such a linked data event stream on top of an existing backend, that's custom work, of course, but from the moment that we have such a streaming API on top of these backends, then we are all really interoperable for the sake of replicating that data. So I find it a really interesting question, and I hope we can really work towards that goal, because if we get TNITS instances everywhere across the world and they don't update, then that will be a really bad publication for TNITS. Everyone will think, oh, but this TNITS is really bad because it doesn't update. Yeah.
Okay, thank you very much for that. Let's go to the next question, which is for ISO 14823. Do you include the country in TNITS?
Yeah, I think that's for me. No, we do not include the country in the sign classification in TNITS. I may have misunderstood the specification or the ISO 14823, but I do believe that the GDD code is unique across countries, while it can be represented with different graphics in different countries. So a speed limit sign is 12557, independent of which country you're in, but they look a bit different from country to country. Or maybe the speed limit sign is perhaps not the best example, rather the zebra stripes sign or whatever. This walking guy look different from country to country.
Okay, thank you very much. And I think this it's also for you, Knut. How are updates, deletion of, for example, speed limits modeled, and how much does TNITS fit for dynamic speed limits on the variable message sign, for example?
Yeah, that's two very good questions. Updates and deletions are handled by the road feature. The road feature can have an attribute that describes whether this feature is an update or an deletion, or it's a new new instance. So that's taken care of in the model. When it comes to dynamic speed limits and variable message signs, if you have variable speed limits or variable message signs with kind of fixed sets of messages and fixed time periods, for example, that you have 40 kilometers per hour by a school or in a street outside of a school in some fixed time, then you can model it using the conditions. But if you have fully flexible dynamic signs, then of course such a model is difficult to implement those kinds of information, that kind of information.
Thank you very much.
Maybe just to add to that, the typically leading map providers, in their databases, they store the location of, for example, variable message signs. So it would be like a point feature in a specific database. Of course, the dynamic information is not included in that. It's just the point location where such a sign is located.
Okay, thank you very much. So that was the last question from my presentation, but we have a last minute question now, and it's to Christian. So Christian, you said that Tnits is used for exchanging data about changes in road attributes. But what is the baseline changes, updates compared to what? So what are they compared against?
They are compared against, real world, I would say. So the whole idea behind Tnits is that there are already different existing databases, and those databases will then be updated going forward. And so this is why we are using Tnits really as an update mechanism. But on the other hand, there are also databases available on the country level. So, for example, the Scandinavian databases, Norway, Sweden, and Finland, they have a whole database which gives the baseline. And when you do then baselining with this databases, you can use the Tnits process to maintain your databases and to keep it fresh and updated. So.
Okay, thank you very much. And for example, instead for countries that do not have a database available already, I would imagine that the first release of the Tnits database would be the baseline, no?
Can be the baseline. So, and then it's delivered out in different data sets. So this can be done via Tnits.
Okay, thank you very much. I don't think we have any other question for the moment, and I would really like to thank all the speakers today and also all the attendees for your participation and your questions. It was a great webinar, and we are pretty much on time. I would like to wish you a very nice end of the afternoon and the day, and we're looking forward to meet you again during our next webinars starting from September, I think.
Okay.
Perfect. Thank you very much, and have a nice evening. Bye-bye.
Bye.
Yeah. Bye-bye.
Bye.
Bye.